This is basically going backwards. So we're going to start by graphing the piecewise function. These should all come out looking like absolute value graphs. And then I'm going to ask you to give me the, once you have the graph, see if you can write me the equation in, like it's an absolute value, not in piecewise. Get what I'm saying? All right, so first of all, when I go to do number one, I'm only going to do the first one with you. Oh, maybe, I don't know. We'll see. We'll see how far we get. So first of all, if I'm going to graph this as a piecewise, I notice that it splits at 5. So I will put a dotted line at 5. Okay, now when I go to graph what is over here, I'm faced with this. I don't know quite how to graph this as it's written. However, I could just distribute the 3 and then combine like terms, and then it would look like y equals mx plus b. Basically what this is kind of in point slope form. They just added or subtracted the 6 to the other side. So I do need to take just a second. It would be easiest if I just rewrote it in y equals mx plus b. So that would be 3x minus 15 minus 6. Oh dear, so I'm really at 3x minus 21. Uh-oh. And 21 is going to be way off my graph. We're going to have to put some thought into that. Let's try the bottom one, see if it's any better. Negative 3x plus 15 minus 6. Okay, that one I can do. Negative 3x, and that's a plus 9. So, out of character a little bit, but I'm going to graph this bottom one first because I have its equation and it's not way off the grid. My other one's way off the grid, so I'm going to come back to that. So this one, 3x plus 9, it only lives on the right-hand side of my dotted line, right? So I'm just going to sort of set myself up. I would normally start at 9, and then I would go where? Down 3 over 1. So I can continue to go down 3 over 1. Hopefully I don't run out. Down 3 over 1. Down 1, 2, 3 over 1. 1, 2, 3 over 1. So when I hit my line, what should it be? Oh, yes, but it should be closed or open? Closed, yes. Remember that you can sort of sidestep all that by just taking 5 and plugging it in directly. So if I just take 5 and I plug it in, negative 15 plus 9 is negative 6. So I can jump right there. So it's going to be a little bit better for us. Instead of graphing it like we normally would, take this number and plug it in and see where we're at. Okay? Anyway, this I can continue with a slope of negative 3 over 1. So this would look like this on this side. Now, hopefully, since I already know that this is an absolute value graph, I'm hoping that the other one just kind of goes this way, right? So let's see. If I took 5 and I plugged it in here, right? Take 5 and plug it into 3x minus 21. What comes out?
6.
Close. Negative 6, right? Because I'd have 15 minus 21. So I'd be starting here. So normally I would put an open dot here. But since there's already a closed dot, remember how we talked to close and an open dot on top of each other is just closed? Yeah.
What if, like, that was an open dot and, like, the second equation was supposed to be a closed dot, would you leave it open?
No. Anytime that there's open on top of closed or the other way around, it's always closed. Yeah. So my point would have been right here anyway, and then I just have to draw a graph that has a slope of 3. So normally you'd go up 3 over 1, up 3 over 1, but this doesn't live over here, remember? So instead of going up 3 to the right one, I can go down 3 to the left one. And yes, that's exactly what I was expecting it to look like. Because absolute value graphs are always V-shapes, they're always symmetrical. So I have a nice looking absolute value graph. Now my question to you is, can you write the equation of that absolute value graph? You can, if you remember these pieces. Remember y equals a absolute value x minus h plus k, right? And then hk is just a vertex, so where's that? What's the coordinate of the vertex?
-5, -6.
Oh dear.
Negative.
-5,
I'm getting really worried. 5, -6. You said 6, -6. I thought. Or I misheard you then. 5, -6.
-6. Well, like going in. Oh, no. I was thinking in the.
Right, when I plug it in, it's going to change. But that vertex is at 5, comma, -6. Does everybody agree? So I apologize if you said it and I misheard you. So 5, -6. Michelle, I think you'll need one of these. We're just finishing up the first one together. Thanks. Okay, so now, whoa, where's all my stuff here? Okay, so now there's my h and k, and then what's the slope of the right-hand branch? The right-hand branch now. -3. So I'm just going to plug in a -3 for A, and then x minus h would be -5, and then k just stays like a -6. It's not too bad once you get the hang of it. It's just going the other way. And you can always double check yourself, right? So this thing, imagine I didn't have any of this. I just started you off with that equation. Well, I would know a couple of things. It should have a vertex at 5, -6, and it should be an upside down V because that's negative, going down 3/1 on the right hand side. Oh, lo and behold, that's what I have. Look at us go. Do you want me to do the second one with you? All right. So the second one, let's see here. So my graph here is splitting at -6. So I'll put a dotted line at -6 where the split is. Just help myself out. And these are not they're not in y equals m plus b form yet, so I'm just going to distribute the -1/3 and combine like terms. So that would be -1/3 x. What's -1/3 times 6? -2, and then I have a +7. So I really get -1/3 x plus 5. Yeah, everybody's okay with that one? Then I'll do the same thing on the bottom. That'll be 1/3 x plus 2 plus 7, so that's a +9. All right, so let's see what we can do. I can go ahead and graph this like I normally would and work backwards a lot, but it would be a lot faster if I just plugged in -6. What's -1/3 times -6? 2, and 2 plus 5 is 7. So when I plugged in -6, I got out a 7. And according to this right now, it should be an open dot, but I have a feeling it'll eventually be closed. So there's a point on this line, and now I just want to make sure that my line has a slope of -1/3. So I would normally go down 1 to the right 3, but it doesn't live on this side of the line, does it? It lives on this side. So instead of going down 1 to the right 3, I can go up 1 to the left 3. I don't have room to do another one, but that's okay. So there's that side. Now let's see if we can do the right hand side. So again, I'll plug -6 in directly. 1/3 times -6 is -2. -2 plus 7, plus 9 gets me a 7. But this time it's closed. So that's going to close up that spot now. And now I just want to continue this line with a slope of +1/3. So from here, I can go up 1 to the right, 1, 2, 3. Up 1 to the right, 1, 2, 3. Once you have your absolute value graphed, try and write its equation. Everybody think they've got it? Joe, go ahead.
Y equals 1/3 absolute value x plus 6 plus 7.
So, I'm going to pretend like I don't know any of these things. You tell me if this matches what I say. Does your absolute value graph have a vertex at negative 6, 7?
Yeah.
And does the right-hand branch have a slope of 1/3? Then his equation is correct. How'd you do? Pretty good? Okay, so your homework, let me stop this video.